All right, today we're going to take a look at section 13.2, which is reflections and glide reflections. All right, so we're starting with the reflections part of it. If we have a point P and it's reflected over a line L, we would call its mirror image the point P prime. The line L would be called the reflecting line. If P is actually on L, it doesn't change. So P is equal to P prime. If P is not on L, then L becomes the perpendicular bisector of the segment PP prime. A reflection also reverses the orientation of the image. So when you think about your hands, it's a very good example. So if you were to put your hand up like this and then you were to do a mirror image, this happens all the time with selfies. Well, that may be the first time I actually said that out loud on a video. All right, so if you ever look at somebody doing a selfie in the video, whatever's behind them is actually reversed. So I had a friend do a Facebook Live video actually this weekend, and I know her house because I was at her house this past week, and it has the word family on the wall, but in her Facebook Live video, it's backwards because it has reversed the image. So you guys are going to watch it and you're going to be like, oh my goodness, I didn't realize that they did that when they did, but they do. So if you do that with your hands, and if you think about, so like let's make the line of my face right here be our reflection line, then this would be the image and this would be the pre-image, or vice versa. Their reflections would actually reverse the orientation. So here are my thumbs on my, well, it's on my, I don't know, my thumb's closer to my head on both sides, which is the opposite side. Okay. A reflection is also another transformation that's an isometry. It preserves distance, preserves length. Remember, that's what our definition for isometry was, is that it doesn't change any of our lengths. All right, so to construct a reflection, there's several ways to do that. One way is by folding something, okay? So if you had sort of this half of a tree image in the first picture, and you folded it along the line, and then you traced it, you could get the full tree image, which would be the right-hand side, where it's shaded in green, and you'd have the other side of the image around that line of reflection. Do I have it on another slide then? Let's see, I do. Tracing paper is a great way of doing that, especially because it's so thin. So if you use tracing paper, you can see how this image works. In fact, they've done such a nice job with this image. They've even reversed the orientation of the letters themselves. So see how this B is pointing to the right, but when they reflect it, the B is pointing to the left. They've actually physically changed even the orientation of the points themselves. And that is the new point B prime. Of course, the picture is the same. It's congruent, right? That's what isometries do. It's a congruent shape. It actually mentioned something in the previous slide, and I didn't draw it, so let me draw it in here. If I were to connect B to B prime, what you would notice is that the line L is perpendicular to that black line that I just drew, and it is the perpendicular bisector. It cuts it equally in half. Otherwise, the distances wouldn't have been preserved. And you can do that with every point, and not even just the vertices, like every point. So we could take some arbitrary point like right here and figure out that it mapped to this point right here and do the same thing.
So could you say that those are parallel? Like if you connect the 2 points at the top and the 2 C
yes,
points?
Yes, that would be true. Yeah, all of these lines that connected across would be parallel because they'd all be perpendicular to the reflecting line.
And when we do these, if we label our shapes to help us, like remember, do you expect that we label them backwards?
No, you don't have to do the reflection of the images. All you need to do is to label the B and the B prime. That's sufficient, yeah. It's just a really nice picture to see it happening, and that's why I've got it in here like that. Yep. Okay, we're going to do another one, though, that is without tracing paper. So this one is a dot grid, which we are just fine if we're shifting things up, right, and left, and right, and whatever. We did the rotating. That was a little trickier, right? It's also a little bit trickier when you do it with the reflection. So you have to be careful. You can still fold the paper, so if it helps you to think about folding your paper to get this image, feel free to do that. So what you're seeing right here is you're seeing this point right here on the line, right? It's not labeled, but you see a point that's actually on the line L. When that point's reflected, what happens? Stays the same. So this is a really good reference point for what's happening. Does that make sense? I don't need to move that point. It will stay there. So everything that gets reflected here is going to have to go through this point right here. Okay, good so far? All right, so if I reflect this, go ahead and fold this. Try and fold this on your paper. See if you can figure out where the image is going to be. Obviously, it's going to hit the dots. That's the whole point. Okay, so it better be hitting the dots on the vertices and so forth, because that's the idea behind a dot grid. And then we'll make sure that you have the image drawn correctly after you've had a chance to do so. And just so that we have points to actually talk about, I'm going to go ahead and give mine points, names. Just the vertices. That's all we really need. Okay, so we already said C stays put. Where's D going to be? From point C.
It's like right below, 2 dots below.
2 dots below. So Emily thinks it's right here. What do you guys think?
Yep.
Agreed? Okay, that was not good. Let's try that again. Let's try that. Okay? So where would point, we're just going to follow our figure around. We went from C to D, so we'll go back up here to point A. Where would point A be? To the right of the D I just drew, right? So, and I should label these D prime. And then A prime would be here. Okay? How about B? Up 1 from A, or A prime. Whoops. Like that. And then I just need to complete the figure, right? To connect C and C prime to point B prime. If you fold it on top of each other, it should line up, at least mostly perfectly, within some, reasonable amount of error. All right, so let's think about ordered pairs. What happens when we actually flip ordered pairs along lines of reflection and specific types of lines of reflection? So one would be over an x-axis. So if you reflect across the x-axis, that's the first one. The second one is a reflection across the y-axis. The third one is over the line y equals x. And the fourth one over the line y equal negative x. So go ahead and write those in, and then I'll chat about them so that I'm not trying to talk while you're thinking. Okay, the x-axis, where is that? What kind of a line is it? It's the horizontal line, right, along the axes. So think about what happens when you reflect something that's above the x-axis. Where will it reflect? Below. The distances all have to stay the same, so the y value doesn't change when you do that, right? So that's why you see, the x value doesn't change when you do that, because the distance left to right doesn't change. So that's why you see the a staying the same. But the y value went from being a positive, i.e. above the x-axis, to being a negative, which would be below the x-axis. So that's what you're seeing happening to the y values. B becomes negative b. Okay? Now, if you're doing a reflection over the y-axis, that's our vertical axis, right? So again, we reflect over the vertical axis like this. Okay? What's changing? Well, it's the x values that change. If you're on the left side, you're negative. On your right side, you're positive. So those are switching places. But the distances away are not. That's why all the A's are staying A's and all the B's are, none of the distances are changing, right? It's just the location of the positives and negatives. So again, if you're actually just flipping over the y-axis, you're not changing if you're above or below the x-axis, so you're not changing the x values, the y values, positives and negatives. It's just the x values that you are. All right, let's actually draw the y equal x, because that one's an interesting one. Okay, that was not well placed. Let's try that again. All right, so if you have a line y equal x, the line y equal x would look something like this. That's pretty good. And if you take an ordered pair, and we'll just take an easy one right here, and you flip it over that line, you can see that it's going to have to form a perpendicular. So if you drew a perpendicular line from that point, it would look like, or look something like this, right? And the distance would have to mirror the same distance that you were away, which means your point would be right here. Okay, that's what visually it would do. Now think about what happened to the xy ordered pair. This one was the point 2, 1. 2 to the right, 1 up. This point becomes the point 1, 2. 1 to the right and 2 up. So the x and the y values simply switch places. Now, the reflection of the line y equal negative x does the same thing, except you see that the signs change as well, which should make sense, right? Because x equals negative y or y equals negative x, either way, changed the sign of the same thing. And we could do an argument with the picture, same thing we could, but I'm not going to draw it. But that would be the same kind of a picture as what I just drew. All right, so I want you to take a minute, using this information or reasoning through it piece by piece if you prefer. I would like for you to take the point 2, negative 3, and find the reflection across those 4 different lines. The x-axis, the y-axis, the line y equal x, and the line y equal negative x. Okay, so you're going to write down 4 ordered pairs. Okay, that's what you're going to do. Starting with the 2, negative 3, write down 4 ordered pairs after each one of those reflections. What did you get for the x-axis one? 2, 3. Did everybody get 2, 3? Okay, great. How about the y-axis? Negative 2, negative 3. Wonderful. Okay, what about y equal x? Negative 3, 2. So we just changed the order, right? No signs changed, just the order changed. And what do we do for line y equal negative x? 3, negative 2. You have to be careful. You can do it one of 2 ways. You can either go back to the original one, switch the order and change the signs, or you could look at the one you just did on C and just change the signs from C because it already switched to the order. Your call. All right, this is actually a excerpt from a textbook, like a middle school textbook, 6th grade math is what it's from, okay? And it's asking the student to actually decide if each of these reflections, these image, or not reflections, each of these transformations, what it is, what kind of transformation has happened. They tell you to decide if it's a slide. What else did we call a slide? This was a translation, so the different resources will use different words, translation. What do you suppose is flip? That's the reflection. Can you see that orange on that? It's not ideal, I guess, but it's not too bad. Let me try a yellow. I think that'll be better. All right. And then the last one is a turn. What's a turn? That's a rotation. A little bit better. All right, so there are 5 questions here. Here's the catch. There's at least one of them where you have more than one option. Like you could describe it in more than one way. Okay, so what I'd like for you to do is to write down what you believe is happening, how you would describe it. Now here's the catch. If you are saying that it's a reflection, you need to draw the line of reflection. Okay? If you're saying that it is a turn or a rotation, you need to say the angle and the direction of the turn. Is it counterclockwise? Is it clockwise? And by what degree? And then if it's a slide, you can talk about being left, right, up, and down, kind of a description for now. We're not going to talk about units because there's no units on here, okay?
Can't have more than one or they can't.
You only need to describe one of them, but some of them have more than one possible answer.
Would you say we have to put if it's a slide?
Just say left, right, up, down, which of those kinds of directions it went, basically. And it's not altogether helpful because they haven't told you where they start, but let me actually put that in too. I'm just using the image on top as A, and the image on bottom is the image, or not image, but the figure on bottom as the image, that'd be A prime. Just so we're all talking about the same thing. When you have your 5 done, compare notes with somebody nearby. And remember, if you have something wrong, like different, it doesn't necessarily mean either of you has to be wrong. So see if you can reason out if you are in fact making a mistake, or if there's just one where you've described it differently and that's okay.
Yeah, it could be over the direct. It could be like or it could be an well, no, I think it's either way. They're both or is it simple? Yeah. Is it just 180?
Yeah. Yeah. Like I walk in and she's
Okay, let's compare notes. You guys do such a good job of talking to one another about these. I appreciate that. What did you decide, or you and your partner or the group you were talking to, what did you think happened on number 1? It's a reflection. Good. Or you can call it a flip if you'd like. A reflection, and did you draw the line in? Did it look something like that? Pretty close? Excellent. What was 2? A rotation or a turn. Or a reflection. Yeah, it can be a reflection as well. So if you do rotation, what would it be? So if you do rotation, it would be clockwise is how we usually say it. Clockwise, 90 degrees. And it's about this point that's totally not labeled because this resource doesn't label things apparently. But let's call it right there, point P. Okay? Oops. So clockwise 90 degrees. Around P. Okay, it also could be a reflection, you're right. So if you do it as a reflection, what did you say?
The diagonal.
So it's a reflection. And I'll draw the line of reflection in. I think that you're describing something like that. Okay, good. Yeah, so those are 2 options on that one. They're both work. Nice. What did you guys write for 3? Translation. And just for the sake of discussion, what or how is it translated? It is down and right. Yes. How about number 4? Half turn or rotation. And again, they don't label it, so let's call it Q.
It can't have like 1 and 1 reflection.
Yeah, you'd have to reflect it twice, and we're using just 1-step changes at this point. At least that's how this resource would have been asking it. So the reflection wouldn't work. But you're right. I mean, we could do a series of reflections to get there too. So if we're just doing 1 step, then it would be a rotation. So a rotation, how much and how and what was it? Yeah, 180 degrees. Do we need to say counterclockwise or clockwise?
Nope.
We don't have to because it's 180. You can if you want, but 180 around Q. You do need to label that it's around Q. We've talked about that last time, that we could rotate, but it doesn't have to be around the same point. And then what about number 5? It actually had some reasoning to it.
I didn't know whether to say they're
Okay.
If like Paul says it's clockwise and he's right, and Marie says it's counterclockwise and she's right.
Okay, so it kind of depends on I drew in the A and the A prime, right? And they don't label whether or not it's a counterclockwise or a clockwise or anything. So they need to be a little more explicit, don't they? A little bit more clear in their directions about how it's being rotated. So they both are sort of partially right, right? They have not really given enough information to either one be completely right, but neither one is completely wrong either. They're just not giving enough information to justify their position. So we're going to say, I think, something like this: both are partially right.
That's kind of like that one on our test with the teacher and the student.
Yes, and I still need to talk about that, and I don't have time to today. But yeah, so the teacher and the student with the test question that you had on exam number 1, please remind me on Friday, and we'll just start with that on Friday so that I can discuss it, because it's an interesting feature, and most of you got to the point where you got that ironed out, but not everybody did. So they're both partially right. I'll just leave that right here because we already discussed. All right. The last piece about reflections here. Reflecting light off a mirror. So there's a wonderful image here, and you can see the flashlight bouncing the light off of the mirror. We actually create 2 angles, and the 2 angles are congruent when we do this. The angle of incidence is the angle that is formed by the incoming ray of light and a light perpendicular to the mirror. And then the angle of reflection is the angle that is created between the reflected ray, the light that's coming off the mirror, and a line perpendicular to the mirror. And you can see a wonderful picture over here where they've labeled them, right? Here's angle of incidence, and here's the one they're talking about, and angle of reflections right here.
Is there one for like what the whole angle is? So they're
No,
both just like
they're just 2 separate angles, right? Yeah, and they are congruent angles, and the reason they're congruent is because you could actually set up some triangles to talk about this in the same way if you wanted to, much like we did back in in chapter 12 when we were doing things with triangles. So, all right, I'd really like to finish this up, so we're going to talk about glide reflections, and then I have one piece of thing to read to you. A glide reflection is actually 2 translations in one. So now we can do that, Amy. This one actually is the first one that does this. A glide reflection consists of a translation, so it's a slide, followed by a reflection. The reflection is in a line parallel to the slide arrow. So you see the foot, and it has moved from where it was originally sort of hollowed out to where it is in blue. That's the translation. And you can see the dotted line that goes from A to A prime in blue up there, right? So that dotted line in blue is going to be parallel to the line of reflection that is in the solid blue below it. And then we reflect the blue footprint over onto the yellow footprint. And that is our second image, if you will, since we've done 2 transformations. Okay? So it's called a glide reflection. And it is another transformation that is an isometry. Okay, another isometry when we do that. All right, and this actually has a very nice application that you have probably heard before. So I'm going to read it to you just in case you haven't. But one night a man had a dream. He dreamed he was walking along a beach with the Lord. Across the sky flashed scenes from his life, and for each scene he noticed 2 sets of footprints in the sand, one belonging to him and the other to the Lord. When the last scene of his life flashed before him, he looked back at the footprints in the sand, and he noticed that at many times along the path, there was only 1 set of footprints. He also noticed that it happened at the very lowest and saddest points of his life. It really bothered him, and he questioned the Lord about it. Lord, you said once that if I decided to follow you, you'd walk with me all the way. But I have noticed that during the most troublesome times in my life, there's only 1 set of footprints. I don't understand why, when I needed you the most, you would leave me. The Lord replied, my son, my precious child, I love you, and I would never leave you. During your times of trial and suffering, when you see only 1 set of footprints, it was then that I carried you. So, that's it.